This demonstration overviews TraNCE, a new system for processing nested collections on top of distributed platforms. So we will first look at how to build an Nrc query interactively with the Query Builder. In the initial view that you see here, users can start a new query session by clicking this plus in the upper right-hand corner, or they can select to edit an existing query. For the demo, I'll be editing this query here. TraNCE provides an Nrc Query Builder that is based on the Blockly API. Each of the expressions in our source language are provided in the Nrc tab. These expressions can be used to build up Nrc programs. For the demo, I will integrate an additional dataset copy number to the existing nested query that is within the builder frame. So I can select this for loop and I can drag it over. And I do want to show that even though I'm choosing copy number, this is where you can select various inputs. Another thing to note is that our original Nrc expression has nested types. So we have this mutations collection and it has this inner sub-expression occurrences, and we have this scores attribute and it has this inner aggregate that iterates over a nested collection inside of occurrences. So we're going to remove this score here and we're just going to throw it out, and then we're going to drag in the copy number data and define the conditional between the resources, and then put them back into their place with some integrated values. And note that we can choose various mathematical operations if we would like to. So when I'm clicking and dragging, you can see that the Nrc code is generating on the right hand side. I can then click to validate the code. Now that the code is validated, we can move on to the compiler view. So now we can compile and run this query. We want to do both the standard and the shredded compilation routes. So the shredded compilation route introduces shredding techniques that basically says for each of these levels, so we have a top level, a first level, and a final level in this query. So for each of those levels, we expect to see a flat expression associated that in the shredded Nrc tab. So we'll go there now and we'll see we do have these 3 flat expressions here, and we can explore the label domains if we want to. So going back to the source Nrc, maybe it's a bit confusing to see the shredded Nrc alone. You can hover over the occurrences to see the associated shredded expression. You can also go over to the standard plan and you can see the plan associated to the standard compilation route. And basically what we see here is that it's going to be a plan that has nested output type, and you can see that in order to produce this, we've done these unnest operations and these nest operations. And these are the types of operations that cause inefficiencies when executing on a distributed platform. So if we go over to the shredded plan tab, we can see that we again have these 3 plans, one for each of those flat expressions we saw in the shredded Nrc tab, and also one for each level that's associated to the source Nrc query. But we can view this side by side with the shredded Nrc expressions, and hopefully you can tell here that these plans are a bit more simple than what we saw in the standard plan, meaning that they'll be a bit more efficient when we execute them in a distributed setting. So here we're just doing some basic projections, and any aggregates that we do end up being on flat objects. So one more thing I want to show here is that we can compile out to notebooks. And this is basically allowing the user to interact with the generated code and extend any of the outputs. So now we're going to look at the results view. And here you're provided with a plot that overviews the data. The graph shows the number of tuples in each nested collection for each top level tuple. So in this case, the size of mutations that we built up. When I select a specific sample size going into a mutation set, the graph has now changed, and you can see that what we're actually viewing now is the next level nested collection size. So in this case, the gene score tuples that we had built up. Metrics are also provided that show the size of partitions for each compilation route. So note that the standard route has a lot of empty partitions, that's the blue line, and very few large partitions, whereas the shredded line stays pretty stable throughout. So if I scroll up here, you can see how extreme the standard partition size does get. Finally, we link out to a Spark event log where the users can see metrics provided by this backend target. So that concludes the demo, and thank you for viewing, and we hope to see you at the booth.